Hey again, this is Mr. Lum, and today in chemistry we're going to be talking about sufficient kinetic energy and the kinetic energy that that reactions need for a reaction to go from reactants to products. So what I wrote here is a few little notes about sufficient kinetic energy. If there's not enough kinetic energy, then the reaction will not proceed to products. So here I have a graph here, and on this graph is potential energy. So here's potential energy, and this one is reaction proceeds. Now, what we see here is that if a reaction has a certain amount of potential energy, it needs to increase its potential energy in order for a reaction to proceed to products here. Now, if a reaction doesn't have enough potential energy, the reaction will come up, and if it has potential energy but only has this much potential energy, it'll come up here and get very, very close to reaching the activated complex, and then it'll fall back down to the reactants. Okay, so the purple line here, it'll come up, and then if it has enough potential energy, if it has enough kinetic energy changing into potential energy, it'll get all the way to the very top and then proceed to products. If it doesn't have enough kinetic energy, it'll get up and then come back down. Now this depends completely on if two molecules are hitting each other with the correct alignment. Okay, so if two molecules are hitting each other with the perfect geometry, okay, then they'll come up and they'll hit each other, and then if they have enough geometry, if they have the correct alignment or the correct geometry, then and enough kinetic energy, then the reactants will hit each other, they'll come up, and they'll turn into products. Now, if they do not have the correct geometry, okay, so not correct geometry, then it is still possible for a reaction to happen. However, they just need to have a higher kinetic energy. So this orange line right here is reactants hitting each other, but they don't have the correct alignment, or they don't have the correct geometry, and they require a lot more kinetic energy. So I have written here a little bit of notes. So molecules have to hit each other at a specific angle in order to react. If they do not have the correct angle, it is still possible for them to react as long as they have extra kinetic energy. So here's the extra kinetic energy that they need to have, going all the way up here, that extra. So this is if incorrect alignment, and this one would be for correct alignment. Correct alignment. Okay. So we're going to look at two molecules, or two reactants, reactant A and reactant B right here, and they're going to have correct alignment when they hit. So this one is going to come in, reactant A is going to come in and strike with reactant B with the correct alignment. And what we see is that reactant A and B hit each other and they form an activated complex. Okay? And then the activated complex is very, very short-lived. So the activated complex is very, very short-lived, and what we see is that at that point right here, reactants come to hit each other, and now it has formed an activated complex. And here's the activated complex right here. So here is activated complex. Okay, and that's what we get right here. It has a lot of potential energy and it's very, very, very unstable. But now, after it's gotten to this point, it's very unstable and it's going to separate, and then we get what is called products. So we have reactants, then up here, activated complex, and then down to products. Okay, now we can have the exact same thing. Here is the same reactant A and reactant B, and they're going to hit each other, but this time they're going to hit each other with incorrect alignment. So what happens again is they hit each other with an incorrect alignment, and you still can get an activated complex. Okay, this activated complex is more unstable. It has a higher potential energy, but it can still react. It just needs a lot more kinetic energy. So you have an activated complex here, and then you get a little bit of mixing over, and you can still get products. And we see right here we have the exact same products in both, but the difference is that it had an incorrect alignment, and therefore it needs much more energy. Okay, so again, activated complex is at the top right here, and we can see the difference in energy it needed. It needed this much more energy because it didn't have the correct alignment. Now, again, we're going to look at this one right here, and this black line right here is the potential energy. This is the potential energy, and when it increases, what it's doing, how the potential increases, is that it takes kinetic energy, and kinetic energy is decreasing. Kinetic energy is decreasing and being changed into potential energy, and that's why potential energy is going up. Kinetic energy is decreasing, and potential energy is therefore increasing until it reaches an activated complex. And the potential energy is very high, and the kinetic energy is very low, and then it releases some of that potential energy and becomes products. Okay, and this one, and therefore it gains some of its kinetic energy back, and it's products here. So at this stage right here, these are products over here. Okay, this stage right here, this is the activated complex, and at this stage right here, this is the reactants. Okay, so we can see very clearly how potential energy and kinetic energy are related. Now, as we know from some of our conservation laws, energy cannot be created nor destroyed. And if you were to put on here, onto this graph, total energy, so onto this graph, let's put total energy, which is going to be the kinetic energy plus the potential energy. If we add this red line plus this black line, we'll see that the total energy is right about here. Okay, for reactants. Now again, if we add this line right here, this red line plus this black line, it stays the same the whole way. And if I was good at drawing, this would be our total energy, would be a perfectly straight line. So this is our total energy. Okay, so here's our total energy right here, which is kinetic energy plus potential energy, which is not changing at all. Okay, it's just right at the beginning, kinetic energy is being changed into potential energy. Then after the activated complex, potential energy is being changed back into kinetic energy.